All right, last but not least, we have type 3 problems. So, a golfer strikes a ball from the top of a 2.3 meter tall hill to the green below. The initial velocity of the golf ball is 28 meters per second, 45 degrees above the horizontal. Determine the golf ball's time of flight, range, maximum height, and final velocity. All right, so type 3 means we're launching at an angle from a height. So step 1's always the same, and step 1 is always in my class and always in all of physics to draw a picture. So we've got a golfer. He's on top of a 2.3 meter hill. My hill is more like a cliff and not a hill, but that's okay. And he strikes the golf ball from the top of it to the green below. So here's the green. I'll give it a cute little flag. And we're going to hit this golf ball. And that angle is 45 degrees above the horizontal. And that initial velocity is 28 meters per second. And we need to find the range, the time of flight, and the maximum height. And the final velocity. So let's look at how we're going to solve these type 3 problems. After we draw our picture, we're going to label our directions. So I'm going to draw my compass. Positive, positive, negative, negative. Makes my life super easy. All right, and then I'm going to label variables. So my x variables are my range, my horizontal velocity, my change in time, my y variables, are my vertical displacement, my initial velocity, my final velocity on the y-axis, my acceleration, and my time. My acceleration is negative 9.8 meters per second squared. All right, let's see what else I can fill in from what I know about this problem. I know this is 28 meters per second. And for every vector, I have to have an x and a y component. So I can figure out this x and y component down here. And I'm going to redraw this triangle just to make it a little bit easier to see. We know this is 45 degrees. This is 28 meters per second. We know this is y, my initial vertical y. We know this is x. So this is going to be 28 sine of 45. This little guy down here is going to be 28 cosine of 45. So my initial velocity, or my horizontal velocity, is 19.8 meters per second. My initial vertical velocity is 19.799 meters per second. All right, step number 4 is always to find that change in time, that elusive change in time. We've got everything we need. Oh, I forgot to label a variable, sorry. Our horizontal, or our displacement on the y-axis is, our final displacement on the y-axis is it's 2.3 meters below where it started. Now I have everything I need. I have 3 out of the 4 kinematic variables I need to solve for this change in time. So step 4 is change in time. Let's come down here and let's solve for this change in time. So displacement on the y-axis is equal to my initial y velocity, change in time, plus 1/2 acceleration, change in time squared. My vertical displacement is negative 2.3 meters. My initial velocity on the y-axis is 19 point, I'm just going to round that to 8 meters per second. We're looking for change in time, plus 1/2 times negative 9.8 meters over second squared, change in time squared. I'm going to take out units to make this a little bit easier to see. I'm going to multiply all of this out. I get negative 4.9 change in time squared. I'm going to multiply all of this out. I get positive 19.8 change in time. And I'm going to bring this over here. Plus 2.3 is all equal to 0. So we have a quadratic equation that we need to solve. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug in what I have. Change in time is equal to the opposite of b, negative 19.8 plus or minus the square root of 19.8 squared minus 4 times a, negative 4.9, times c, positive 2.3, all over 2 times a, which is negative 4.9. When you do your math, you'll get 2 answers. Your first will be that your change in time is negative 0.11 seconds. Your second will be that your change in time is equal to 4.15 seconds. We can't have a negative change in time. So we have to go with this 4.15 seconds. So I'm going to come back and plug that in. Our change in time is 4.15 seconds. Step 5 is range. All right. So velocity is equal to a change in displacement over change in time. So 19.8 meters per second is equal to our range, which is what we're looking for, over 4.15 seconds. So our range is equal to 82.17 meters. So I can plug that in. All right, our last step is to look for our maximum height. Or our next step is to look for maximum height. Now I'm going to get a clean sheet of paper just so I don't have to keep moving this around and you can't see the variables anymore. All right, so our final velocity squared is equal to our initial velocity squared plus 2 times the acceleration times displacement. All right, so we're going to plug in what we have. Our initial y velocity is 19.799 meters per second. All right, plus 2 times negative 9.8 meters per second squared. This is what we're looking for here. We have to fill in something for this velocity though. And we're looking for our velocity at our max height. So when we're at our max height, our horizontal or our vertical velocity at our maximum height is 0 meters per second. Because at that maximum height, it stops moving for just a moment before it starts going down. So we're going to use that 0 meters per second. That's where we're looking for this change in vertical velocity. We're going to work our problem. And we are going to get that our vertical displacement change is 20 meters. But we're already 2.3 meters in the air. So if we want to know our maximum height, we need to know what that is plus those 2.3 meters we already have. So 22.3 meters is going to be our maximum height. So when this y is 0, we're at 22.3 meters above the ground. The last thing we're going to have to look for is our final velocity. All right, so let's look at step 7. We're going to use the same equation before, but now we're actually looking for what this final velocity is. We're not going to say it's 0 because we're looking for what it is at the very end. So our final vertical velocity is equal to 19.8 meters per second squared plus 2 times negative 9.8 meters per second squared. We want to know what this is when our displacement is negative 2.3 meters. All right, so I'm going to plug in what I have, or I did plug in what I have. I'm going to get that my velocity is plus or minus the square root of 437.12 meters squared per second squared. So this final vertical velocity is going to be negative 20.9 meters per second. Again, I chose the negative because I know when we land, we're looking at this velocity going down. So I can draw my triangle. My golf ball lands. This y is 20.9 meters per second. My x never changes, so it's 19.8 meters per second. So these are what I'm looking for. A squared plus b squared equals c squared. So 20.9 squared plus 19.8 squared equals final velocity squared. So my final velocity is 28.79 meters. Now I need to know the angle at which it hit at. So the tangent of theta is equal to opposite 20.9 over adjacent 19.8. So theta is equal to 46.5 degrees. So therefore, the golf ball's time of flight was, let me do 4.15 seconds. The range was 82.17 meters. The maximum height was, oh, it's right here, 22.3 meters. And the final velocity was 28.7. So I could say 29 if I'm looking at significant figures, meters per second, 47 degrees below the horizontal. And we're done.